Dear students, today you will learn new topic PN junction diode of chapter 14 semiconductor electronics. Now before starting the PN junction diode, I will briefly introduce you to semiconductor material. As you know very well that on the basis of electrical conduction, the solid can classified mainly in three categories: conductor, insulator and semiconductor. The conductor have electrical conductivity ranging from 10 to the power 2 to 10 to the power 8 Simon per meter. And the conductivity of insulator lies between 10 to the power minus 11 to 10 to the power minus 19 Simon per meter. Whereas the semiconductor have the conductivities lie between 10 to the power minus 6 to 10 to the power 5 Simon per meter. Thus, we can say the conductivity of the semiconductor materials lies between the conductor and the insulator. Due to this reason, semiconductors have important role in fabrication of electronic devices. And this semiconductor material can be classified into two categories: intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductor are the pure semiconductor like silicon or germanium, while the extrinsic semiconductor are produced by doping the pure semiconductor with a small amount of certain impurity. Therefore, the extrinsic semiconductor can further classified as P-type of semiconductor and N-type of semiconductor material, and that depend on the doping impurity atom. Now, let us discuss these two types of extrinsic semiconductor. First, N-type of semiconductor. This semiconductor is produced by doping a pure semiconductor like silicon or germanium with the pentavalent impurity element such as phosphorus, arsenic, antimony, etc. As dopant atom have sites similar to this parent atom, when we introduce it in pure semiconductor silicon, it will displace this silicon atom within a crystal. The 4 of 5 electrons of pentavalent impurity atoms will form covalent bond with the valence electrons of neighboring silicon, and the 5th electron is loosely bounded with it. And this electron can easily detach from this pentavalent atom, which required energy for this purpose is very low, 0.05 electron volt for silicon and 0.01 electron volt for the germanium. And when this electron is detached, the impurity atom becomes positive and it behaves as a donor ion. In this type of semiconductor, the electrons are contributed by this donor and the thermal generated process. So, the electrons are majority charge carrier, while holes are only generated by the thermal process. So, the minority carriers are holes in N-type of semiconductor. On the other hand, P-type of semiconductor produced by adding in a pure semiconductor with the trivalent impurities such as boron, aluminium, gallium, etc. The 3 valence electrons of this impurity atom form covalent bond with the 3 neighboring silicon atom. But one neighboring silicon atom is left incomplete due to deficiency of one electron. This deficiency form a positive vacancy or hole in this incomplete bond. Then an electron from neighboring silicon bond can trap into this hole and will create a vacancy or hole in that bond. And thus, impurity atom will behave as a acceptor ion. As hole are created by acceptor impurity atom and thermal degeneration, hence hole are the majority carrier in P type of semiconductor and electrons are the minority carrier in P type of semiconductor. Now, here I am discussing PN junction diode. It is a schematic diagram of PN junction. How we can produce semiconductor diode? To fabricate PN junction diode, we introduce trivalent impurity on one half side and the pentavalent impurity on the other half side of pure semiconductor crystal. So there are two type of regions, P region and N region. And the boundary between these two regions is known as junction. Here you can see in P region, because of the trivalent impurity, the number of holes are more than electrons. So in this region, the majority charge carriers are hole and the minority charge carriers are electrons. In this region, acceptor ions are equal to the number of holes. Hence, P region is electrically neutral. On the other hand, in N region, due to pentavalent impurity, electrons are majority carrier and holes are minority carriers. Thus, due to equal number of donor ions and electrons, N type of region is also electrically neutral. Now this is the symbol by which we can represent PN junction diode. It has two electrodes, one on the P side and one on the N side. It is called diode due to two electrodes. The arrow shows the direction of conventional current flow. P side behave as anode and N side behave as cathode. So it conducts current in one direction. Therefore, PN junction diode is also known as unidirectional semiconductor device. Now, how the depletion layer occurs at the PN junction. Here you can see in P region, the concentration of holes are greater than the holes in N region. Also, in N region, the concentration of electrons are greater than the electrons in P region. So, because of this concentration gradient, the hole diffuse from P to N region and electron from N to P region. Now, when donor atom release these loosely bound electrons, the donor atom becomes positive immobile ions. And when these free electrons cross the junction and trap on the holes, the acceptor atom becomes negative immobile ions. And this region of immobile ions, which is free from the charge carriers, is known as the depletion region. Due to accumulation of negative charge in P region and positive charge in N region, a potential difference is set up across the junction and which further oppose the diffusion of charge carrier in the junction and act as a potential barrier. And the direction of the potential barrier or internal electric field across the junction is from N to P region. The potential barrier for the germanium crystal is 0.3 volt for germanium and 0.7 volt for the silicon crystal. Now let us discuss the current flowing in unbiased PN junction. Unbiased means when there is no external electric field applied to the PN junction diode. In unbiased PN junction diode, the diffusion current flow due to the diffusion of majority charge carrier. But diffusion current decreases as potential barrier not permit the majority charge carrier in the junction region. But only those majority charge carrier will cross the barrier, will have sufficient thermal energy, and very small diffusion current will flow at the junction. Now, this potential barrier drift the minority carriers, due to which drift current will be flow. At the equilibrium, the diffusion current and the drift current become equal and opposite, hence the net current at the junction will be zero. Now, we bias the PN junction diode for the current conduction. We can bias the PN junction diode by two ways on the basis of external electric field direction, forward bias and reverse bias. First, we will discuss PN junction diode under forward bias. In forward biasing of a PN junction, we connect the P region of junction with the positive terminal and N region connect with the negative terminal of the battery. Now, in this case, holes are repelled from the positive terminal and the electrons are repelled from the negative terminal of battery and move toward the junction. Because of this, energy of some holes and electrons increase and enter to the depletion region, due to which potential barrier is decreased and hence more majority carriers diffuse across the junction. Now, when electron reach to the end of P side, it is attracted by the positive terminal of the battery. And when hole reach to the end of N side, the electron move from negative terminal of battery and enter to the N region, due to which forward current flow through the PN junction. Here you can see in plot the current increase very slowly initially, which is due to the potential barrier. But when we increase the external electric field above a certain voltage, current increase rapidly. And this voltage is known as knee voltage. Its value is 0.7 for silicon and 0.3 for germanium. Now, PN junction diode under reverse bias condition. In reverse biasing, we connect the P region to the negative terminal and N region to the positive terminal of the applied external electric field. The holes in P region are attracted toward the negative terminal and electron in N region are attracted toward the positive terminal of the battery, due to which the width of depletion layer is increased and junction act as an insulator. But a small current flow across the junction due to the minority charge carrier, which is called as reverse current or leakage current. In plot, you can see this small leakage current. But when we increase the reverse voltage, this reverse current suddenly increase to the large value. This voltage is known as breakdown voltage. This is due to at high potential, the number of covalent bond breaks and thus increase the charge carrier's concentration and hence produce high reverse current across the junction. Due to these unique characteristics, PN junction diode have wide range of applications, such as it can use as a rectifier, it can use as a LED, as a voltage regulator. Diode also can use as a switch in digital logic circuits and can use in clamping circuits as wave shaping circuit in computers, radio and radars.